Solving quadratic equations using the quadratic formula. One way to solve quadratic equations is by using the quadratic formula. Like all the methods of solving quadratic equations, this one has its advantages. The best advantage of the quadratic formula is, in my opinion, that it works with any quadratic equation. If you stumble upon a real tough equation, this formula can bail you out, but only if you're willing to take the time to check your work carefully to make sure you make no mistakes. In this lesson, Joe will use the quadratic formula to solve some equations. Solving quadratic equations with the quadratic formula has one thing in common with solving by graphing and solving by factoring, and that is, to start, the equation must be solved for 0 on one side of the equation. If it's not already solved for 0 on one side, it needs to be solved for 0 on one side of the equation. You might recall working with the equation for the axis of symmetry of the quadratic equation, which is x equals negative b divided by 2a. The quadratic formula is the same as the equation for the axis of symmetry, but with the addition of plus or minus the square root of b squared minus 4ac. If the solutions come out as irrational numbers, some teachers like to have you put the solutions in simplest radical form. In this lesson, however, we'll mostly take the decimal form of the answers rounded to the nearest tenth place. The first equation we'll solve is this one: x squared plus 14x plus 45 equals 0. The first thing we do is lay out the ax squared plus bx plus c equals 0 standard form of a quadratic equation, which is ax squared plus bx plus c equals 0. For this equation, it's already in standard form. X squared has no number in front of it, so a equals 1, b equals 14, and c equals 45. Wherever there's a letter in the formula, we place a parenthesis for a number to be inserted. The b is 14 and is inserted here and here where the arrows are pointing. The a is 1 and goes here and here where these arrows point, and the c is 45 and goes here in this one place. With all the numbers in place, this is what the quadratic formula looks like at the bottom. The first thing to look at is the number under the square root sign, or radical. This number, with everything worked out, is called the discriminant. One way of thinking why it's called the discriminant is because this number discriminates between real solutions and imaginary solutions. If we find this number to be positive, we go ahead and solve, but if it's negative, we know that there are no real solutions, and a lot of the time we need not go any further. When we calculate the discriminant, here it's 16, so we know that we have two real solutions to the equation. The square root of 16 simplifies to 4, and we continue to solve and have negative 14 plus or minus 4 divided by 2. Dividing or separating the formula into two parts, there is negative 18 over 2 and negative 10 over 2. The simplified roots of their solutions are negative 9 and negative 5, so x equals negative 9 and x equals negative 5. Joe will now look at this problem: negative x squared plus 3x equals 3. The first thing we do is put the equation in standard form. For that, we need to move out the 3 on the right side to the other side of the equal sign. The positive 3 becomes minus 3 on the left side of the equal sign, and the equation becomes negative x squared plus 3x minus 3 equals 0. In the ax squared plus bx plus c equals 0 standard form of a quadratic equation, a equals negative 1, b equals 3, and c equals negative 3. In the quadratic formula, the a, or negative 1, goes here in these two places, the b, positive 3, goes in these two places, and the c, negative 3, goes in this single place. The most mistake-free way I know to do this is to have a quadratic formula with parentheses to be filled in, like this one below. And here is the quadratic formula form filled in with all the numbers for a, b, and c. The first thing we calculate is the discriminant under the square root sign. This simplifies to 9 minus 12, or negative 3. And since the square root of negative 3 is a non-real answer, we can say that this quadratic equation has no real solutions, no real numbers for x that make this equation a true statement. However, we can go ahead and get complex number solutions to the equation. We get x equals negative 3 plus or minus 3i over negative 2, which we box in as our correct answer. The imaginary number unit I is defined as the square root of negative 1. Joe will look at this quadratic equation, x squared plus 6x equals negative 9. Just like solving by graphing or by factoring, the first step is to get one side of the equation equal to 0. We move the negative 9 that is on the right over to the left of the equal sign where it becomes positive 9. So now we have x squared plus 6x plus 9 equals 0. And we next identify the a, b, and c from the standard form of the quadratic equation. And the a equals 1, b equals 6, and c equals 9. We place the numbers for a, b, and c into the correct places of the quadratic formula. We check the value of the discriminant, which is under the square root sign, and get 36 minus 36, which equals 0. So that makes everything after the plus or minus sign 0, and the whole thing simplifies to negative 6 divided by 2, which simplifies to negative 3. So x equals negative 3, the case of only one solution, which can be called a double root or a solution with a multiplicity of 2. Let's look at this quadratic equation. 3n squared minus 6n minus 12 equals 0. Stop the video and solve the equation using the quadratic formula. Restart the video after you have found your answer to see how you did. The first thing we notice is that the equation is already in standard form. We identify a, b, and c from the standard form of a quadratic equation. The next thing we do is put the numbers into parentheses for each of these numbers. We check out the value of the discriminant. It simplifies to 36 plus 144 or 180. So this equation has two real solutions. The formula simplifies to approximately 6 plus or minus the square root of 180, which is about 13.4. So the formula splits into 6 plus 13.4 over 6 and 6 minus 13.4 over 6. And here are the calculations in our view screen. We make certain to get the numbers right by putting the numerators in parentheses when entering them in the calculator. Sometimes teachers like the solutions in simplest radical form, but the teacher for this particular problem has asked for rounding to the nearest tenth, at least for this problem. So here are the solutions. X equals approximately negative 1.2 or 3.2. The quadratic formula may not be the easiest method of solving depending on circumstances, but it has a great advantage which cannot be ignored. The method works for any quadratic equation. And here are the 5 different methods of solving quadratic equations that we'll be covering in my series. We have the square root method, solving by factoring, solving by graphing, using the quadratic formula, and completing the square. You may click on any of these to go to that particular lesson. In addition, there is a solving quadratic equations flow chart that filters you through the different techniques of solving these types of equations. This has been solving quadratic equations using the quadratic formula. Thanks for viewing.